Hi, my name's Iain Galloway with NXP Semiconductors. We have a small mobile robotics group within NXP, the larger NXP, and we're proud to bring you quite a few different solutions that you can use in your own designs. NXP as a company has a long history in automotive, industrial, medical, and other high reliability industry sectors. So most of those parts really apply very well in the mobile robotics area. We're happy to provide these solutions to you so you can accelerate your time in developing both hardware and software. There's an additional website link here shown here that shows solutions tailored a bit more closely to mobile robotics and UAVs or unmanned aerial vehicles. In our organization, we started initially with this sort of a block diagram representing a much more modern, say, drone architecture. It fits also with other types of mobile robotics vehicles, rovers or seagoing vehicles. And the key thing is that we focus around having a CAN bus. We think that the idea of connecting with a CAN bus really is robust. It can be redundant, and it also leads towards what could be considered a distributed architecture where processing can take place at different places and then a shared data distribution system communicating those results between different modules. You'll be familiar with this vehicle management unit. This would be a PX4, PixHawk type flight controller, and then a companion computer being a Linux-based companion computer. We've introduced also the concept of using one of the automotive TSN, time-sensitive network Ethernet switches. And in particular, we're focusing on T1 Ethernet, which is a lightweight 2-wire Ethernet implementation. So this follows many parallels to our activities in the automotive industry with autonomous vehicles and safe and secure, functionally secure architectures. But unlike automotive, these small vehicles really also mirror IoT devices and edge compute devices because typically they're not transporting a person. Of course, you could, if they're transporting a package, yes, but then there's also lots of IoT in terms of use cases where you're sensing or doing survey type applications. So we have created all of these reference designs for you to use and leverage to get to market faster. In addition to the NXP reference designs, there are third-party designs that use our chips and provide also additional software support. I wanted to also highlight that on most of our products, the majority of our products, we include some form of secure element. And SE050 is one of the more public, easy to use, supported secure element. It's a hardware enclave for cryptographic keys, encryption algorithms, and it can provide even backup or additional support in an already secure system. So you may have a companion computer that's has secure booting, but at a later date you want to allow late key injection. Say you want to authorize someone to use this or perform this particular flight, or you want to take a module that's securely booted up and associate it with a particular vehicle. So those are some of the things you can do with secure element. Our first product was the RD Drone FMU K66. So this reference design is a PixHawk compatible PixHawk V4. It uses our Kinetis microcontroller. And some of the differentiating features are that it has T1 automotive Ethernet. So that's this 2-wire Ethernet I mentioned. Does support dual CAN. There's, of course, IMU elements on board, a number of them. And the secure element is there with an NFC interface now on the latest iteration. So that would, even if you're not going to use this board in an end product, but you wanted to work on the security aspects of PX4, here would be a good starting point. Of course, we continue to do lots of software updates to this and provide examples on using this with ROS and ROS2 and bridging to off-board mode on a companion computer. The flight FMU K66 is part of a larger drone reference kit called KIT, HG Drone K66. This drone was developed for people to have a full turnkey solution, and it's also used within HOVERGAMES, hence the HG part of HG Drone. So it's a complete kit with the RC remote, debugger, all the accessory components. It's a decent 500 millimeter size carbon fiber frame. There's a full gazebo model for this. And the only thing you need extra is we can't ship LiPo batteries, so you have to get a LiPo battery separately, and you select which telemetry radio you need to use depending on your frequency for your region. So again, it runs the industry standard PX4 software. The flight controller has 2-wire Ethernet. There's lots of space for expansion. And we have a full Git book that documents the HOVERGAMES drone experience and how to build it. One of the new pieces we prepared in order to support automotive Ethernet is a T1 adapter. So this is a small dongle-like board. It is a quick evaluation board. The files are all available if you wanted to make them yourself, but the intention was to allow things that had a traditional large RJ45 connector to mate in with a small T1 2-wire twisted pair system. So the T1 adapter is a reference design, and it can be used, for example, like to connect a laptop into a T1 format network. You could put 2 T1 adapters between 2 different boards, or you could have a single board embedded Linux machine connecting into a T1 network. The components are very simple. There's a Ethernet PHY called TJA1101, a small LPC, NXP LPC microcontroller that all it does is set up the bridge and sets up the 2 PHYs. There's a second traditional 100 base T PHY, and then it can be powered either by USB. There's a small USB connector you can't see on the bottom side, or hardwired into a board, a single board computer, for example, providing it 5-volt input for power. Coming soon to work with this system is a T1 Ethernet switch. We've had this in testing for a while. We're just trying to get this out the door so it's available on NXP.com. But this is it's a 10-port switch. We've built this board to be small, credit card size, and use 8 of the 10 ports. You can see that there's 6 T1 PHYs here, T1 connection. The PHYs are actually built into the switch chip itself. There's a traditional large RJ45 jack, and that's a 100 megabit jack, and then a IX Industrial. So this is a new standard, small form factor, ruggedized Ethernet connector that our mobile robotics team has been working with quite a lot lately. So it's a nice small size, physical form size. It's still traditional 100 base, well, this is gigabit, so it's a 1000 base T network. So this is a reference design. Again, 6 2-wire Ethernets, 100 base TX, 100 gigabit Ethernet with the IX Industrial. The NXP parts on board are an SJA1110 10-port Ethernet switch. The other 2 ports here are RGMI ports, so you could use it to bridge between multiple higher-end processors, for example, or cascade from one switch to the next. There is an automotive power management IC, so it does work at higher voltage inputs, very wide range, and a rugged voltage input capability. And there is also a secure element on board with a NFC NFC interface, so that could be used for programming authentication or connecting or allowing certain network activities to take place. And it's in a very small board form factor. Now, if there's more intensive development planned on this board, we do provide a software image that runs and works as a switch for evaluation. But if you're doing intensive evaluation, there's a full-size evaluation kit from our vehicle networking department. And so that can also be used for your own development purposes. Next board I'm going to talk about is our battery management reference design. So this is a full battery management board based on our automotive chipsets. Could be used for robotics, but also suitable for medical or industrial cases. Maybe you're building power tools that are battery operated, or military batteries, that sort of thing. It has CAN and SM bus and security and NFC. So again, one of the differentiating factors here is it is a microcontroller driven design. There's a battery charge controller and an automotive K1 S32K144 microcontroller. There's a secure element that can do things like authentication or crypto keys, but also, say, secure cycle counts, or perhaps if you have to flag a secure flag that says this battery pack has been intentionally abused, maybe under voltage because you had to land or fly home, you may want to record that permanently so that it doesn't get used for other con ops for your vehicle. Again, there's an NFC interface using an NTAG device, and this would allow, say you have 100 battery packs on the shelf for your drone operations, you could quickly check them with an NFC reader or even a cell phone to say what's the last state of charge and what flags might be set. For the CAN interface, we use a system basis chips, which is an analog part that provides both CAN and voltage regulation. Our latest iteration does also allow for an OLED display, so you can get localized display input. And we have provided software, and we've been doing regular software releases that are compatible with PX4. So you have a console that lets you see state of charge, state of health, set parameters for different battery chemistries, etc. Really quite comprehensive battery management board. I wanted to also point out that these battery cell controllers are designed for automotive use, and they are designed to cascade up to larger cell count. So here we only have 6 cells, and it's built for a traditional LiPo battery type of configuration. But there are pins that allow you to daisy chain these up to very high voltages. And in order to support UAVCAN, and you'll see that there have been a number of our colleagues here at NXP that are presenting on UAVCAN and talking about this new standard or updated standard, UAVCAN V1. We prepared what we consider a node board, and that's literally a quick small form factor adapter. It's got an S32K1 automotive processor. It's got dual redundant CAN buses. So this allows a daisy chain in and out, and then there's CAN 1 and CAN 0. The debugger interface port, and then really the intent here is you've got a couple of PWM outputs. You can also have SPI, I2C, UART. This runs NUTX, and it has a PX4 target, so it is a PX4. It's not a flight controller, it's a node, but the really interesting part there is that then we can have a distributed architecture. So if you hooked a GPS and an IMU onto this, it could actually calculate, let's say, an EKF and provide that back into the system. The flight controller would just see it as another set of DDS services batteries, publish, subscribe type event. We have a new version that's about to launch called S32K1 SIC. So SIC stands for Signal Improvement CAN PHY. We wanted to show the benefits of this new PHY, which has active ringing cancellation, and it works very well for a robotics application where you may have short stub lengths. It could allow things like a star topology within a CAN bus, which is not normally what you would see. All right, the parts on board are the S32K146 automotive microcontroller. The PHY typically is this TJ1044, and the secure element on board as well. We did provide software. We have software so this can be programmed to be a debugger running SLCAN. So maybe you have Wireshark running on a laptop, you load SLCAN on this board, and then it provides a CAN interface for your laptop. which would let you debug a larger CAN system as well. So a little bit about the signal improvement CAN PHY that I mentioned. The main point of this is to facilitate larger and even or star-based CAN FD networks where you may have signal ringing. And here's a bad case of signal ringing where you're really not settled when you're sampling the CAN state, right? You don't know whether there's a 1 or a 0 depending on what your sample point is. Whereas a CAN, the SiC part, has active signal improvement and really settles out the signal very quickly. So this either can extend the speed of your current network or let you do some new things. Now, the nice thing is they're direct replacement for other existing high-speed CAN transceivers, so CAN FD transceivers. And what we're trying to show, for example, is that if you literally brought the CAN parts together in a star topology, you could implement a network like this, and the CAN SiC transceivers would be able to manage normally what you would get is very bad ringing on a topology like this. So a network could save you up to 30% in cable length in this type of example, rather as opposed to going in and out of each node. I'd like to point out a few commercial solutions that are using NXP parts that partners or friends of ours that we like to promote because of their applicability. Of course, the first one is Auterion. Auterion SkyNode is de facto standard for PX4 based flight controllers, and it uses an IMX8M Mini as its mission controller. It's based on FMU V5X, and it also implements secure element SE050. Auterion provides an enterprise Linux distribution, and of course it follows the drone code connector standards. So that's available directly from Auterion. For motor controls, there's a third party that uses our components. We work closely with them. The company's called FetTech. So they use automotive controllers and have done a number of custom designs for specific customers that need that kind of high reliability motor controllers. They're able to, here's an example, some are 60 amp, some are 90 amp. They can support up to 10S or 42 volt input. There's telemetry feedback. They can support different ESC standards like double D-shot and one-shot, and available with security components built in. For ultra-wideband, NXP is a world leader in ultra-wideband. This is a challenging area to work with right now because of the high demand in the cell phone and automotive industry. So they are taking up the majority of the bandwidth. So we have some internal research that we're doing, internal planning and studying and enablement. It's not quite ready for prime time for mobile robotics audience, but there are third parties, particularly called themobileknowledge.com, that provide reference boards and software support using off-the-shelf modules from companies like Amotech and Murata, and they use our chipsets. We hope to have some software demonstration and enablement for PX4 in the not too distant future, and be able to demonstrate precision landing on a moving platform using ultra-wideband localization in the not too distant future. And another third-party product is NAVQ companion computer. This is from, we worked with MCraft on this one for HOVERGAMES, but we don't, NXP does not provide this board as a retail product. It comes from MCraft. The claim to fame here is that the SOM itself is identical to our NXP reference design, or EVK, but then we have a custom carrier board to support the needs of drones. So you can see UARTs and high voltage input, that sort of thing. We did include a secure element on board, and we have Gitbook documentation on working with this board. That's based on IMX8M Mini. We do supply, it comes with a Google Coral camera. And now for some work in progress, things we're working on. And the first one is NAVQ Plus. So the NAVQ was successfully used in HOVERGAMES. It is available from MCraft. We, NXP, are now working with MCraft to have NAVQ Plus as a standard NXP reference design. So that uses our IMX8M Plus processor. And it's a quad ARM A53 and with a neural net accelerator. There's hardware accelerated vision codecs, and it has dual camera, dual USB, dual CAN FD, and dual Ethernet on board. The NPU, the network accelerator, runs about 2.3 TOPS. We are enabling it with Ubuntu and ROS 2, so it's well supported under ROS and Gazebo. There is our streamlined Yocto development environment for custom Linux as well. But we have some exciting news planned with Ubuntu and Ubuntu Core on this board. So for vision, it does have dual MIPI camera inputs with accelerators. There are ability to bring in USB and Ethernet cameras and also run them through some of the accelerators or codecs. We will be supporting Wi-Fi 5 and Bluetooth Low Energy, BTLE5, BT5. Dual Ethernet, one is 100 megabit T1 2-wire Ethernet, so there won't be any adapter needed to go into a 2-wire automotive Ethernet system. And the other will be the IX Industrial 1 gigabit, which will plug directly into the Ethernet switch that I showed you earlier. There are two USB-Cs, which can provide power in or out up to 20 volts. And there's a separate hardware connector here for up to 20 volt power input. Secure element is on board. There's a NXP real-time clock with tamper detect time stamping. There will be an ability to do a PCIe expansion. So if you wanted to include or put in a standard LTE cell modem, for example, that would be possible. And then the chip and the board also supports HDMI output with CEC, so it could be used in a multimedia or controlling a monitor. But the other displays that it supports simultaneously are LVDS, so direct to glass, or a MIPI DSI interface. So we see this also as a nice module for use in a ground control station or possibly in a specialized industrial remote control unit, RC remote control. Here's a bit of a tour around the board. Again, the two USB-Cs, some UARTs, the gigabit Ethernet on an IX connector, the 2-wire automotive Ethernet on a 2-wire connector, CAN FD here, dual in and out, the NFC that's connected to secure element, the HDMI port, some UARTs, a SPI port, power in and power out. Power out is if we wanted to provide power over to a PCIe expansion. There's time of flight camera available for it, and there's also a standard camera will be supporting the Google Coral Cam. We have a list of all the compatible components here, and with one of them coming from a third party. We do have a few things coming that are not listed here yet, but stay tuned. And finally, I want to talk to you about HOVERGAMES, a coding challenge. We are expecting HOVERGAMES 3 to come quickly in probably the very end of this year, the very start of 2022. Again, it's a coding competition. We hold this online. It's open to most places in the world. And we really use this to promote PX4 to the world and get new developers involved in the PX4 community. We usually pick a societal challenge. So our first challenge was help fight fires with flyers, and our second one was help people in pandemics. will be a similar societal theme coming up, likely focused on edge compute, AI, and ML, and a lot of collaboration opportunities here. We've had huge interest and great success with our first two HOVERGAMES programs, and we expect to see the same thing in our third. So in closing, I'd like to really recommend, if you're interested in any of these designs, they can be used. All the files are provided. All the source code is provided. It's all open source. There is some ability to use even more advanced algorithms that are, unfortunately, the business line has some of those things that are not open source, but you can certainly integrate them into your end product. You could get a HOVERGAMES reference drone or buggy. You could join us in HOVERGAMES 3, where we also provide a discount on these items, and then look for NAVQ Plus being available at the end of the year. This will all be announced a bit more detail here on hovergames.com when we're ready with that. If you have any need to talk to us directly, you can please reach out. Iain Galloway, that's me, Gerald Peckler in Europe, and thank you very much for your time.